This video is the fifth of a series of tutorials discussing the LX7720 radiation-hardened motor driver for space. First, here's a reminder of what the LX7720 actually is. The LX7720 is a mixed-signal peripheral, which works with an FPGA or a microcontroller to build a complete closed-loop brushless DC motor controller or stepper motor system. The first two videos outlined the LX7720 at a system level, and then dived into a detailed discussion of the half-bridge FET drivers. Videos 3 and 4 introduced the LX7720's 4 current sense amplifiers and showed how to use a current sense amplifier in each of the 3 common current measurement topologies used with motors. This video discusses separating a half-bridge into independent low-side and high-side drivers and how to use current sensing in these cases. Each of the LX7720's 4 half-bridge driver stages contains an individual high-side and low-side NFET driver. In normal use, the combination of a high-side and a low-side NFET driver is used as a pair to form a half-bridge, as shown here. In this example, high-side current sensing is applied. Alternatively, since each half-bridge's high-side and low-side drivers have independent control signals, the drivers can be used independently. This can be useful for 3-phase motor driver applications because typically the 4th half-bridge is bare and therefore can be used as an independent high-side and an independent low-side power switch for other applications. For example, with high-side current sensing, the low side is gently separated, carefully avoiding the smell of burning electrons. Although the two drivers are now independent from each other in terms of output load and control signals, the gate drive VGS and V-float voltages are still shared with the other half-bridge drivers. This doesn't have a practical effect for the low-side driver, and the output load voltage and current is only limited by the choice of NFET. The high-side driver is limited to switching the VMPS motor supply used by the other half-bridges. This is because the V-boost supply, common to all half-bridges, operates relative to VMPS. Now let's consider another half-bridge, this time with low-side current sensing. Again, the block can be split, providing a high-side output plus an independent low side at this time with current sensing. As before, the gate drive VGS and V-float voltage sharing doesn't have a practical effect for the low-side driver, and the output voltage and current is again only limited by the choice of NFET. Again, the high-side driver is limited to switching the VMPS motor supply used by the other half-bridges. Lastly, there's no need to use the current sense amplifier at all if it's not needed. So the final configuration here is a straightforward high-side and low-side driver pair, not using the current sensing at all.